Alright, welcome back. So in this video, we're going to be talking about performance evaluation or the scoring methods that we're going to use in our breast cancer detection. First of all, we have accuracy and we have precision and recall. It's a must, obviously, and the combination of precision and recall would be F1 score. And we're going to have area under the curve, the ROC curve, right? So those are the common ones to use usually. And we would also have scoring time as well as fitting time as additional consideration to use, right? Okay, so I suppose we'll start with accuracy. Okay, so accuracy is actually quite intuitive, right? So essentially, it measures how many observations are correctly classified, right? Both positive and negative. So it measures literally the true results, right? Over true results over the whole cases, right? Over the total number of data, and yeah. So this is the essentially the the formula, right? So we have the true positive over true plus true negative over the whole data, which is true positive, true negative, false positive, false negative, right? And that accounts to accuracy. And yeah, it is actually a valid choice of evaluation for classification problems, which are well balanced and not skewed. So there's no class imbalance, right? And in our data set for breast cancer detection, it is actually imbalanced, but not that imbalanced to the point where we have to try to apply some um, measures in order to mitigate with the imbalance, right? So it's like the data imbalance is um, like um, 3 by like for example the I suppose um, the I think the majority of the data is actually classified as uh, malignant, if I'm not mistaken. There's like a higher amount of malignant data, data, um, cancer data, as opposed to benign cancer data. But I will try to visualize it, the amount of each, just to show that the imbalance is not that significant to the point where we have to you know do additional measure for it. But it's actually, yeah, important to understand it. Okay, so yeah. um, okay, so when we talk about accuracy, right? um, this is how it compares, right, to precision. Simply put, accuracy is when you hit the center of the bullseye. Like, how far are you from the center of the bullseye? So the lower your accuracy is, the further you are from the center of the bullseye, and the higher your accuracy is, um, the closer it is from the bullseye, right? Like, for example, this one, it has high accuracy because it's closer, right, to the to the center bullseye, right? Okay. And I suppose with that, let's talk about precision. So um, I suppose this diagram is actually a great way to visualize it. Um, so precision essentially measures how spread out the data really are. For example, the lower the precision, the more spread out it is, and the higher it is, the closer the data points are to one another. So like for example, on the upper left right here, we have the upper left picture, right? We have data points where the data points are actually not uh, very close to the center of the bullseye, which means it has low accuracy, and it is actually very spread out, and which means it has a low precision, right? And then we have the one on the upper right, where it is actually very far from the center of the bullseye, but they're actually close. The data points are very close to one another, in which it means it has high precision, right? And essentially, for the lower left, we have the data points where they are actually very close, quite close, closer to the center of the center of the bullseye, but they're actually very spread out. They're pretty spread out, you know. But since this is like a circle, like even if they're like spread out, if they are closer to a point, then it's pretty close. But we can say that it has low precision, right? And last but not least, we have on the lower right, right, uh, uh, lower right hand side, we have high accuracy and high precision because it is actually precisely it is actually in the middle, in the center of the bullseye, and they are very close to one another. So with that, let's try to define precision, right? Okay, so precision is essentially the proportion of predicted positives over the truly positive, right? So like for example, if we use the confusion rate matrix right here, so we have the true positive here and total predicted positive, and total predicted positive is actually like true positive and false positive, right? So yeah, it talks about how precise. Wait, no, it's not accurate here, so that's wrong. Okay. Precision talks about how precise the model is out of those predicted positives and how many of them are actual positives, right? Precision is actually a good measure to determine when the cost of false positive is high. In email spam detection, for example, the false positive means that an email is that is non-spam has been identified as spam. You know, so we don't want that because it has a very high cost, right? Uh, so we can actually kind of conclude that precision is a valid choice of evaluation metric if we want to be very sure with our uh, prediction, right? Another example would be like, for example, if we're building a system to predict whether or not we should decrease the credit limit on a particular account, right? So we want to be sure about our prediction, which may, you know, or if we're not if we're not very precise, then it may result in customer dissatisfaction, right? So yeah, uh, okay, so I suppose let's end that here, and in the next video we're gonna talk about recall and F1 score. See you in the next video.